Okay, this again is, I think, one of the absolute crux type of slides to show. We're going to look at how does beamwidth influence gain. Once again, there's actually nice equations, which I don't want to bother with here, but if anyone is interested, there's fundamental limits in terms of how beamwidth and gain relates to each other. So when someone tells you the beamwidth of an antenna, you can actually sort of tell fundamentally what would be the maximum gain that could be obtained from that beamwidth. But in general, if you look at omni antennas, you could have a low gain, medium gain, or high gain omni. That would be quite a high gain omni. And if you look at the azimuth, once again, that's looking from the top. What you want from an omni, of course, is that it radiates equally well in all directions. Now, that's not at all obvious, especially if you're trying to do this over a wide frequency band. If you go to medium gain, you can see that the circle increases. So there's more gain going towards the sides because we're looking from the top. And if we look at these side views, it really becomes clear why this happens. In other words, if you look at the low gain guy, the reason why we got a little bit more gain in the isotrope, by the way, isotrope is something that radiates equally in absolutely all directions. But here you can see we started squashing an isotrope. It's like a balloon that you take and you squash it in the middle, and you can see we can make it increase towards the sides. So we can get gain. While we still got an omnidirectional, never the same gain as what you can get out of a directional antenna, but we can squash it some more, and that will happen. And if we squash it some more, you can get high gain. What you just have to note is that getting this gain is not for free. In other words, you're getting less and less radiation at other angles, okay, in order to get a lot in this direction. So the higher the gain of omni antenna, the more careful you have to be in terms of erecting it. In other words, if this thing is slightly skewed, it could be pointing towards the ground and not give you the actual gain in the direction you're pointing. If you're on a hilly terrain and something like that, the same could happen. And of course, if you're on a yacht or something that tilts, you would rather like this or perhaps this, and that could give you better performance. Directional, pretty similar, except the difference here is that we are squishing the balloon in all directions. In other words, if you look at top view, it's pointing or protruding or bulging in one direction, and the bottom view the same. If you go to, say, a 9 dBi antenna, that's about close to 9 times the power that you would get out of isotrope. You can see that it gets narrower. And if you go to 14 dBi, you can see that this beam also gets narrower. So it also gets a little bit more difficult to align, or you have to do it more careful at the high gain. And if you go to dishes, for example, it could get very sharp. And the medium and low gain you would often use if you actually want to give coverage, like in a Wi-Fi hotspot. If you put it in one corner of a warehouse, you can use this type of gain and you get almost 90 degrees coverage, which is actually a lot better than your typical omni would give you. Just